Good day, my friends. Let's learn something new today.
Today, we're diving into the world of numbers, specifically rational. We use numbers every day, but have you ever stopped to think about why some numbers seem neater than others? Well, that's what we're going to unpack today.
Rational numbers are any number that can be written as a fraction, where you have one whole number divided by another.
So like 1/2, 3/4, things like that.
Exactly. And that also includes whole numbers themselves, because any whole number can be written as a fraction over 1. For example, 5 is the same as 5 over 1.
Oh, that makes sense. So we're talking about fractions, whole numbers, and even some decimals, those that terminate neatly or repeat a pattern.
Precisely. Think about everyday examples. When you're cooking and a recipe calls for 1/2 cup of flour, that's a rational number. Or when you're dealing with money, $0.25 is a quarter, which is literally 1/4 of a dollar.
So we use rational numbers all the time without even thinking about it.
Irrational numbers can't be expressed as a simple fraction. Their decimal representations go on forever without repeating. It's like they have this infinite depth to them.
Okay, so give me an example. I need something I can wrap my brain around.
Well, the most famous irrational number is probably pi, the ratio of a circle's circumference to its diameter. We often use an approximation like 3.14, but in reality, pi starts with 3.14159 and just keeps going and going with no repeating pattern.
So we can never truly, pin down pi to a simple fraction. That's kind of mind-boggling.
And another classic example of an irrational number is the square root of 2. It seems like such a simple concept, a number that when multiplied by itself equals 2, but its decimal representation is also irrational, stretching on infinitely without a repeating pattern.
So these irrational numbers really do break the rules we expect from rational numbers. It's like they're rebelling against the neat and tidy world of fractions.
In a way, yes. They introduce a level of complexity and wonder to mathematics. They fill in all the gaps between those dots. Imagine zooming in on a digital image. At first, you see individual pixels, like our rational numbers. But as you zoom in further, the gaps between pixels are filled in, creating a smooth, continuous image. That's what irrational numbers do to the number line. They make it continuous, an unbroken whole.
Wow. That's a really cool way to visualize it. So irrational numbers aren't just outliers. They're essential for the completeness of the entire number line.
Exactly. They enrich our understanding of numbers and their relationships in a profound way. Pi is more than just a number. It's a fundamental constant that pops up in countless mathematical formulas and physical laws, and its irrationality is a key part of its mystique. Think about calculating the area of a circle. We use the formula area equals pi times the radius squared.
Right. I remember that from geometry class.
But because pi is irrational, its decimal representation goes on forever. And let's go back to that number line analogy we talked about earlier. Remember how rational numbers are like evenly spaced dots along the line?
Yes, providing a basic framework.
Well, irrational numbers fill in all the gaps between those dots. They make the number line truly continuous, seamless flow of numbers with no breaks or jumps.
So irrational numbers aren't just filling in the blanks. They're essential for the completeness of the entire number system.
Exactly. For example, irrational numbers are essential in fields like physics and engineering, where they allow for precise calculations of natural phenomena.
Okay, so these irrational numbers aren't just theoretical curiosities. They have real-world applications too.
Absolutely. They pop up in some pretty surprising places. And remember how we were talking about pi being essential for calculations in engineering and physics?
Yes, it allows for increasingly precise measurements and predictions.
Well, imagine trying to design a bridge or a spacecraft without the precision afforded by irrational numbers like pi. It simply wouldn't be possible.
So even though they might seem messy and unpredictable, irrational numbers play a vital role in building and understanding our world. So as we wrap up our deep dive today, what's one key takeaway you hope our listeners will remember about rational and irrational numbers?
Well, I think the most important thing is to appreciate the fundamental difference between these two types of numbers and how they complement each other. Rational numbers provide a framework, a foundation for our understanding of the number system. But irrational numbers, they fill in the gaps, adding depth, complexity, and beauty to the mathematical landscape. Together, they form the complete picture of the real number line.
That's a great way to put it.